Hello everybody and welcome back to Advanced Maths. Today we're looking at binomial expansion, problems involving coefficients. Before we begin, you really must know your binomial expansion. You must know how to binomial expand a set of brackets. If you don't know that already, you should pause this video and go watch my other video on binomial expansion. I will link that below in the description. You should know from that video that a plus b to the power n, you can find the coefficients of this expansion with this formula. N choose r, a to the power r, b to the power n minus r. Where n is the power, r is each term, a is the first part of the bracket, b is the second part of the bracket. And we can use this to solve problems related to specific terms of the binomial expansion. These are really common exam style questions, so it's really helpful to know how to solve these. So example 1, what is the coefficient of x squared in the expansion of 2x minus 3 to the power 5? So we know that the r is going to be 2 because the power of x is going to be 2. And we can put it in this expression like this, where n is 5, r is 2, a is 2x, b is minus 3. So just replaced each part of that formula with the terms from our expression. And we'll start simplifying that. 5 choose 2 is just going to be 10. 2x squared, remember the 2 gets squared as well, that's going to be 4x squared. And minus 3 to the power minus 3 is minus 27. We now have 10 times 4 times minus 27 is minus 1080 x squared. So now we know the coefficient of x squared in the expansion of that is going to be minus 1080. So part B says, what is the coefficient of x cubed in the expansion of x minus 1 times 2x minus 3 to the power 5? Now just notice this relates to part A, and that's quite common in exam questions. Part B leads on from part A. And we've got x minus 1 times the expansion of 2x minus 3 to the power 5, which is going to look like this, where the red part is the same and the blue part is the same. And here on the right hand side, I'm just imagining what the expansion of 2x minus 3 to the power 5 would look like. Now, we want to make x to the power 3, and we can do that using two of these terms. You can do x times x squared, or you can do minus 1 times x cubed. So there's two ways you would get x cubed when you multiply out these sets of brackets. There is no other way to get x cubed. So we can ignore every other combination, and we only do x times x squared or minus 1 times x cubed. But we know the coefficient of x squared already, that's minus 1080. But we do need to find the coefficient of x cubed to continue. So that's exactly what we're going to do. We're going to use the binomial coefficient formula and just substitute the numbers in, like this. And we solve that. 5 choose 3 is 10. 2x to the power 3 is going to be 8x to the power 3. Minus 3 to the power 5 minus 3 is minus 3 squared, which is just going to be 9. And so 10 times 8 times 9 is 720 x cubed. Substituting that in here. And now I can figure it out. I can multiply out these brackets for the x cubed term. The x times x squared term will be x times minus 1080. X squared will be minus 1080 x cubed. And then we have minus 1 times 720 x cubed. That will be minus 720 x cubed. So the minus sign is again very important. Simplifying this, we will get the combined term is minus 1080 x cubed, etc. So therefore, the coefficient of x cubed in the full expansion of x minus 1 times 2x minus 3 to the power 5 will be minus 1800. And we've solved example 1. Example 2 now, find the constant term in the expansion of x minus 3 over x squared to the power 12. Okay, So when we say constant term, this means the term in the expansion, which is just a number. I've given you a simple example here, where we've expanded x times 1 over x to the power 4, and the constant term will be the 6 in the middle. Because that is the number that doesn't depend on the x's, it is constant, it doesn't change depending on the x's. So whenever you see the word constant term, it just means the term that's just a number. And the constant term will be when it's x to the power 0, because x to the power 0 is 1, and so it's not involving the x, because x to the power 0 just disappears as times by 1. So we are looking for when it's x to the power 0. And that's true every time you're looking for a constant term. Whenever you're looking for a constant term, you're looking for when x is x to the power 0. Okay, and we're going to substitute the power. N is 12, a is x, b is minus 3 over x squared, and r we don't know, into the binomial coefficient formula. Now, we do not know r, so we're going to spend some time trying to figure out what r is. Okay, and the clue we're going to use is that the power of x is 0. So we're going to simplify this a little bit. Minus 3 over x squared is the same as minus 3 x to the power minus 2. And just remember that when you're dividing by x squared, that's the same as the x to the power minus 2. This simplifies here to be minus 3 to the power 12 minus r and x to the minus 2 to the power 12 minus r. Now here, we've simplified it quite a lot, and I've highlighted the powers of x here. So, and those powers of x must be the same on both sides. So therefore, x to the power 0 is the same as x to the power r times x to the minus 2 to the power 12 minus r. And we know that because logically the powers of x must be the same on both sides. So we can equate the powers of x. This is getting somewhere, so let's keep going. We're going to simplify that x to the minus 2 to the power 12 minus r. And it's going to be minus 2 times 12 is minus 24, minus 2 times minus r is plus 2r. So we've got a power to the power, we can just multiply the powers. Now we've got an x to the power r times x to the power minus 24 plus 2r. That can combine by adding the powers. So you multiply them together, multiplying the x's together, so you can add the powers. And so when you add them, you get 3r minus 24. And therefore, these two powers must be the same. 0 must be the same as 3r minus 24. We rearrange that equation and we solve. 24 must be 3r. We divide by 3 and we get r is equal to 8. And so all the algebra we've done so far was just to find out the r we need for this expression to get the constant term. Okay, and now we can substitute r equals 8 into our expression for the binomial term. 8 goes there, 8 goes there, 8 goes there, and 8 goes there. I'm going to simplify, simplify, simplify. 12 choose 8 is 495. X to the power 8 we got to leave the same. Minus 3 to the power 12 minus 8, that's minus 3 to the power 4 is minus 81. And then x squared, x to minus 2 to the power 12 minus 8 is x to the power minus 2 to the power 4. So we multiply the numbers together, we simplify the x's, and you'll realise that it's x to the power 8 times x to the power minus 8, which does add together, the powers add together to get 0, which is what we wanted. And we're left with just the constant term, just a number on its own without any x's, as we wanted. The x to the power 0 term is the constant term. And so the final answer is minus 40,095. Okay. Now example 3. One of the terms of the expansion of ax plus by to the power n is 560 x cubed y to the power 4. Find the values of a, b, and n given that all three are integers. So integers are whole numbers, positive or negative. And what we're going to do is going to make 560 x to the power 3 y to the power 4 equal to our binomial coefficient formula. And we're going to try and find out what n is, what r is, what a and b are. But straight away we can see that the powers are x cubed y to the power 4. And those powers must always add up to n. So 3 plus 4 tells us that n is 7. Now we know that r must also be 3 because we want x cubed, so we want the power of x to be 3, so r must be 3. And we know that the power of n power is 7, so 7 minus 3 would give us the b power as well. So we know n is 7, and we know r is 3. Keep substituting things in. Here we go, substituting everything in, we know, like that. Okay, and I want to really emphasize this. We know that n is 7 because the power of x is 3, the power of y is 4, and those two together must add up to the full power n. So it would be to the power 7 here. We simplify. So 7 choose 3, we can simplify it to get 35. We can expand the brackets there. So ax cubed is the same as a cubed x cubed. By to the power 4 is b to the power 4y to the 4. And again, it is still equal to 560 x cubed y to the power 4. We've got x cubed and y to the power 4 on both sides, so we can just cross those out and get rid. And we're left with 560 is equal to 35 a cubed b to the power 4. We divide by 35. 560 divided by 35 is 16. And so we've got 16 is equal to a cubed b to the power 4. So we need to find two integers a and b where a to the power 3 and b to the power 4 makes 16. And integers need to be whole numbers. And this is where we use a bit of intuition, where we realise that 16 is just 2 to the power 4. And so it makes sense that b to the power 4 is 2 to the power 4. And then we can multiply it by 1 cubed, or a cubed, and make a 1. And so here we've used a bit of intuition, that we know that 16 is 2 to the power 4, so therefore we made the b 2 to make it b to the power, 2 to the power 4. And then we multiplied it by 1 to the power 3, because that's just multiplying by 1. That's where we use intuition and just a bit of common sense with our number facts to get the final answer. So a is 1, b is 2, and n is 7. Thank you for watching this week's video from Advanced Maths Room. So like and subscribe to make sure you get all our latest videos. This video is a long one, so you might want to rewind the video and watch it a few more times. You might want to also rewatch it and pause it before each example and see if you can do the example yourself from memory to see if you really understood the logic behind my worked examples. It will take you a few watches to fully understand this video. If you want more revision resources for IB or A-level, visit advancedmaths.com. Thank you for watching and good luck in your exams.